Hello there, and welcome to AP Calculus, Lecture 2.4b. This is the last lecture that will be contained on your second test. And we're going to do the chain rule, but with trig functions. So, all right. So, I don't have any notes really to give you, just some example problems. So, first example is 44 on page 131. And on that one, we have y is equal to sine pi x. Now, an easier way, this would be, if this were just x, the derivative would just be cosine x, right? What makes it different is that there is something in front of the x. So to help us think about this, I'm going to rewrite it like this. Y is equal to sine, and put parentheses around the angle. So sine pi x. So what we have here, because of that pi in front, we have an outer function that I'm going to do in blue here. That's the outer. And then we have an inner function that I'm going to underline in red. And that inner function is the angle. Okay, so all right. So that makes it a chain rule. So y prime is the derivative of the outer front function. That would be cosine pi x times the derivative of pi x. Well, that would just be pi. So the answer is pi cosine pi x. Now you can take the parentheses away once you do the final answer, but I'm just going to leave the parentheses in there. Certainly nothing wrong with that. All right, let's do another one. Example 46. So basically I'm just doing the even ones in this area of the homework. So h of x is equal to secant x squared. Now I'm going to rewrite this. I'm going to take that x squared and put a parentheses around it to help us understand what's the outer function and what's the inner function. So again, I'll go with blue for the outer function. The outer function is the whole thing, secant x squared. The inner function is the angle. Now, if it were just secant x, it wouldn't be a chain rule. It would be secant x times tangent x, and you'd be done. So h prime of x, the derivative of the outer function, would be secant x squared tangent x squared. Now, we don't have to put the parentheses around the x squared. I did that just to help you understand. So times the derivative of the inner function, which would just be 2x. So to clean it up, we usually bring that 2x out front. Secant x squared tangent x squared. Okay, now we're going to get into a couple that are quite a bit, well, they're about a third more tricky. Okay, so example 48, we have g of t is equal to 5 cosine squared pi t. Now, where we had two layers to our first two examples, we had an outer and an inner. On this, we actually have 3 layers to it. Okay, let me show you how to rewrite this. So this is going to be 5 times cosine pi t all squared. So that 2 right there means to square cosine pi t. And they put it there so they didn't have to put these brackets in. But I went ahead and put the brackets around the angle, all right, the parentheses around the angle, and the brackets around the entire trig function. So we actually have 3 layers here to deal with. So the outermost layer, okay, I'm going to put it down here, would be in blue. So that's cosine pi t all squared. And then you have an intermediate inner layer that's just cosine pi t. And then you have the innermost layer, which I'll show in green, is the angle. Now, what makes this a 3-layer instead of a 2-layer? That 2 right there gives you a 3rd layer to deal with. Okay, so let's take the derivative. So the outermost layer, you bring that 2 out front, so g prime of t. 2 times 5 is 10. 10 times cosine pi t. And then it's to the first, which you don't have to write. Then multiply that by the derivative of cosine pi t. The red, that would be times negative sine pi t. And then finally, times the angle in green. So that would be times pi. So cleaning that up, so we would have 10 pi, and it's a negative. I'm going to bring that negative. And then I usually put sine in front of cosine. Doesn't matter. Sine pi t, cosine pi t. Right? Negative 10 pi, sine pi t, cosine pi t. It doesn't matter which one you put first, sine or cosine. So that's what I call a 3-layer onion. So there's another situation that can give you 3 layers, and that's example number 50. So let's work that one real quick. Okay, number 50 says y is equal to 3x minus 5 cosine pi x squared. So if I have a 2 here, which we don't, but if I had a 2 there, that would make it a 3-layer onion. Or if I have the angle to a power other than 1, that makes it a 3-layer onion. So using our colors again, the outermost, if I put that in blue, is cosine pi x all squared. Then you have an intermediate, which we'll do in red. That's pi x squared. And then finally, what's within the parentheses is our innermost layer. Okay, so y prime is equal to just 3 minus, okay, the derivative of cosine is minus sine, so that minus sign would make it a plus. 5 sine pi x squared. So that's the derivative of the outermost, cosine to sine, and it changed the sign, times, then you have in red, that's pi x squared. That would be 2 pi x. You're bringing that 2 out front and taking it to the first power, which we don't have to write. So times 2 pi x times the derivative of what's underlined in green, pi x. So that would be pi. So cleaning that up, it's going to be 3 plus pi times x. 2 times 5 is 10, so 10 pi squared x sine pi x all squared. Wow, that is fancy schmancy. Now, are you going to have a ton of these on the test? No. Could you get one? Absolutely, you could get one. All right, I wouldn't spend the time on it if I wasn't going to put at least one on the test. All right. Our last example, we're going back to the 2-layer onion. You have sine root x plus root sine x. Well, let's rewrite that as sine x to the 1/2 plus sine x. In this case, so this is different. The angle is to the 1/2. And here the entire expression's to the 1/2 power. Okay, so that makes it a 2-layer onion, but not a 3-layer because there's not something in front of the x. Okay, so we have the outermost in blue, the whole thing, and then we have an inner in red. That's just x to the 1/2. And here, on the second part of this, the outermost is the whole thing. And then the inner function would just be sine x. Now, if there were, it would be a 3rd layer if we had a number like a 3 or a pi or something like that in front of the x. But we don't have that, so that makes life a little bit easier here. So, y prime is equal to the derivative of sine x to the 1/2, the blue. That'd be cosine x to the 1/2 times the derivative of the angle, 1/2 x to the minus 1/2. Plus, okay, the blue part here, that's just going to be the derivative of sine is cosine, so cosine x to the 1/2. Oh, wait a second. Hold on. I'm sorry. Got ahead of myself. That would be bring the 1/2 out front. Let's do the whole thing in blue. 1/2 times sine x to the minus 1/2 times the derivative of the blop, or what's in red, which would be cosine x. Okay. Got to clean this up. I'm going to change those x to the 1/2 back to radicals there. So that'd be cosine root x over 2 times root x plus cosine x is on top. And since it's the negative 1/2, and you've got a 2 there, times the square root of sine x. All right, and that'll do the trick. Okay, so the homework. All right, we're on page 131. Okay, you're going to do 43 through 51 odd. So that gives you practice on the trig ones. That's just the odd ones versus the even ones I worked. And then some others that'll be more practice for the chain rule, not necessarily only trig. 53, 57, 61, 63, 75, and 77. So I want to talk about at least one of these real quick and give you a hint. All right, so just let me bring the book into view here. So once you get past the trig ones here, you know, on 53 and 57, you're just taking the derivative, and they're not trig, so you're using either the chain rule if you need to, or you can just, you don't have to use the chain rule necessarily, but just taking a derivative and then plugging in the x value to evaluate it. On 61 and 63, you're taking the derivative and getting the slope and doing the tangent line equation. All right, so you'll be plugging in pi there to get the slope. So you might need your unit circle for 63. For 75 and 77, so 75 is in two parts, and it tells you which equation to use there. So you can do quotient rule there, or you could rewrite it and do chain rule, however you want to do it. It's really 77 I wanted to talk about. So remember, it says what is the first part of the question is determine the maximum angular displacement. The max that any angle can be, any trig. So if you have, so for our hint for 77, if we have 0.2 cosine 8t, remember the max that the cosine of any angle can be is 1. And the minimum is -1. So if it asks for the max there, you might remember us doing this in pre-cal when we were doing the graphs, and you could go back to those notes. And also on the second part, you're going to have to take the derivative to get a rate of change. Your calculator needs to be in radians. Okay, so it might still be in degrees from physics or whatever, but your calculator needs to be in radians. When you plug the number, I think you're plugging the number 3 in. So when you plug that in, your calculator will need to be in radians to evaluate that. All right, that's all I've got, and I'll talk to you on the solutions video.